Okay, so what we did the other day was we took two vectors and we added them together by putting them tip to tail and finding the diagonal from start to finish, which we called the resultant. So we added two vectors and came up with the resultant. We can do the reverse. We can take the diagonal and we can break it up into two components. So here we took the up and down component and the side to side component and added it and got a diagonal. What we're going to do is we're going to take the diagonal, we're going to break it apart into a side to side component and a vertical component. So all you're doing here is taking a diagonal line and making it go across a parallelogram. So it's very, very simple, I think. So we can think of this vector A as being the addition of these two components. So if I were to add these two together and find the resultant, that's what I would get, would be A. So this is the breaking it apart into two components. This is called vector resolution, and it's pretty straightforward. So here we've got a diagonal, and what you need to do is just basically draw a vertical line and a horizontal line, so that you touch the tips of the arrow, and then go ahead and draw. Now this vector goes up and to the right, or north and east, however you want to say it. So that means I should have a vector that's to the right, and I should have a vector that's up. Okay. So notice what I did is I just made this into a right triangle, and then go ahead and finish it off with your parallelogram. If we wanted to figure out, here's just another example. So just picture basically this is the diagonal across a right triangle or a parallelogram, whatever makes more sense to you. But go ahead and make the right triangle and then finish it off to make the parallelogram. So here's an example of one that you're going to be doing similar on your homework. We've got a plane that's flying 55 degrees north of west at 150 kilometers per hour. Find the component vectors, or find the north-south vector and the east-west vector. So I've done that ahead of time. So what we've got here is the first thing we need to do is we need to figure out how a scale in order for our 150 kilometers to fit on the page but not be too small. So I came up with a scale that 1 centimeter equals 20 kilometers per hour, because I knew using that scale, my 150 kilometers per hour would be 7.5 centimeters. You didn't have to use, you could have used 10 or 12 or I don't know, but 20 seemed to fit pretty well. So we went with that. So what we're going to do is we know we're going to go north and west. So that's up and to the left, which means I need to start kind of bottom and to the right. That's where I want to start. So start by drawing a dot on the bottom right at the intersection of a grid line here. And then take your protractor, and we want to go 55 degrees north of west. So this line right here is west of my dot. This is my west. So I'm going to go 55 degrees north of that. So what I do is I make my protractor and I make a little dot where 55 degrees would be, or this would be the angle of 55 degrees. So now I've got two dots. Now I can make a line. So my scale says to make this line 7.5 centimeters long. So I start at my dot. I go through my little mark that I made for 55 degrees, and then I make it 7.5 centimeters. Okay. From there on, once I've got this drawn, I basically just line up my ruler with the grid lines and finish off my right triangle. So here's my bottom of my triangle, and here's my top of my triangle, or my side of the triangle. And with this is my resultant, or my diagonal. And then I finish off the parallelogram. Okay, and then the last thing I need to do once I've got these done, and notice I put arrowheads on all my vectors. I've got an arrowhead here. It's hard to see, but I've got three arrowheads here, and I've got an arrowhead here. I probably should have put an arrowhead right here too. So I measure the two sides. So this side was 4.2 centimeters. So again, using my scale of 1 centimeter equals 20 kilometers per hour, I get that the horizontal vector is 84 kilometers per hour west, and I measured this from this line here, and I get that my line is 6.4 centimeters. So put that over 1 and then use my my scale, 20 kilometers per hour, and I get that my vertical line is 120 kilometers per hour north. And that's pretty much all you have to do. I don't think it's too bad. Maybe it might be a little confusing at first, but once you get it, it'll be pretty simple. So again, this is just another picture of me having done that. Okay, well, good luck. Give it a go. Do the back of worksheet 3, 3-3, and good luck on it.